1707 Hōei earthquake. The 1707 Hōei earthquake Baoyang Daijin, Hōei jishin struck south-central Japan at 14:00 local time on 28 October. It was the largest earthquake in Japanese history until surpassed by the 2011 Tōhoku earthquake. It caused moderate to severe damage throughout southwestern Honshu, Shikoku, and southeastern Kyūshū. The earthquake and the resulting destructive tsunami caused more than 5,000 casualties. This event ruptured all of the segments of the Nankai megathrust simultaneously, the only earthquake known to have done this, with an estimated magnitude of 8.6 ml or 8.7 MW. It might also have triggered the last eruption of Mount Fuji 49 days later. Hōei Baoyang was the era spanning the years from March 1704 through April 1711. Tectonic setting. The southern coast of Honshu runs parallel to the Nankai Trough, which marks the subduction of the Philippine Sea Plate beneath the Eurasian Plate. Movement on this convergent plate boundary leads to many earthquakes, some of them of megathrust type. The Nankai megathrust has 5 distinct segments at E that can rupture independently. The segments have ruptured either singly or together repeatedly over the last 1,300 years. Megathrust earthquakes on this structure tend to occur in pairs, with a relatively short time gap between them. In addition to 2 events in 1854, a similar pair occurred in 1944 and 1946. In both instances, the northeastern segment ruptured before the southwestern segment. In the 1707 event, the earthquakes were either simultaneous or close enough in time to not be distinguished by historical sources. Damage. The earthquake caused more than 5,000 casualties, destroyed 29,000 houses, and triggered at least one major landslide, the Ahia Slide in Shizuoka. One of Japan's 3 largest, it buried a 1.8 km2 area under an estimated 120 million and 3 of debris. The Nara Basin shows evidence of event-induced liquefaction. Characteristics. Earthquake. The magnitude of the 1707 event exceeded that of both the 1854 Tokai and Nankai earthquakes based on several observations. The uplift at Cape Muroto, Kachai, is estimated at 2.3 m in 1707 compared to 1.5 m in 1854, the presence of an area of seismic intensity of 6.7 on the JMA scale in Kawachi Plain, the degree of damage and inundations heights for the corresponding tsunami and records of tsunami at distance. The length of the rupture has been estimated from the modeling of the observed tsunami and the location of tsunami deposits. Initial estimates of 605 km, based on 4 segments rupturing, failed to explain tsunami deposits discovered at the western end of the trough. Including an additional area at the southwestern end, part of the so-called Hyuga-Nada segment gave a better match, with a total rupture length in the range 675–700 km. Tsunami. Along the southwestern coast of Kachai, run-up heights averaged 7.7 m with up to 10 m in places, 25.7 m high at Kyūshū, Nakatosa, Kachai, and 23 m at Tainzeki. Eruption of Mount Fuji. Evidence suggests that changes in stress caused by large earthquakes may be sufficient to trigger volcanic eruptions, assuming that the magma system involved is close to a critical state. The 1707 earthquake may have triggered a shift in static stress that led to pressure changes in the magma chamber beneath Mount Fuji. The volcano erupted on 16 December 1707, 49 days after the quake.